Hello students and good morning. So now I am doing class for class 11 science. The topic is the same topic that we were doing in the last online class, that is trigonometrical ratios of compound angles. So today is the continuation class for this chapter. Same exercise 4 mark section, page number 139 from the book Higher Mathematics for class 11 by SN Day. So let us do this question number 11. So if tan alpha is equal to x sine beta divided by 1 minus x cos beta, and tan beta is equal to y sine alpha divided by 1 minus y cos alpha, you have to prove that sine alpha divided by sine beta is equal to x upon y. So how can you prove it? So in this case, the values of tan alpha and tan beta are given in terms of x and y respectively. And you have to prove sine alpha by sine beta is equal to x upon y. Okay. Now from the first given, these are the two given conditions. So from the first given condition, let us get the value for x after simplifying it. Okay. So here the first given here is, your given is tan alpha is equal to x sine beta divided by 1 minus x cos beta. Okay. Now let us convert this tan alpha into sine and cos. So this is sine alpha by cos alpha is equal to x sine beta divided by 1 minus x cos beta. So I think you have understood it. Okay. So let us do cross multiplication here. Let us simplify it and get the value for x. Or let us do cross multiplication here. This is x cos alpha sine beta is equal to, now cross multiply by sine alpha here. This is sine alpha minus x sine alpha cos beta. Okay. Now from this equation, from this first given condition, we are getting the value for x. Now you have to keep the terms containing x on the left hand side and all other terms on the right hand side. So let us keep the terms containing x on the left hand side. Okay. So this is x cos alpha sine beta. Then you have to take the term containing x on the left hand side, that is minus x sine alpha cos beta, take it to the left hand side. So it becomes plus, isn't it? Plus x sine alpha cos beta is equal to, this is your sine alpha. So what is common out here? It is x. So within bracket we have cos alpha sine beta plus, this is sine alpha cos beta, which is equal to, here you can write sine alpha. Okay. Or you can write x into, so this is sine A cos B plus cos A sine B. Let us take this alpha as A and beta as B. What is the formula? This is sine of alpha plus beta is equal to what? It is sine alpha. So let us mark it number 1. So is that clear to all of you? So we have simplified the first given condition and we have got the value for x, that is x into sine of alpha plus beta is equal to sine alpha. Okay. So let us mark it as number 1. Similarly, you can simplify the second given condition. So again, what is the second given condition? It is tan beta is equal to, what is here? It is y sine alpha divided by 1 minus y cos alpha. So let us convert this tan beta in terms of sine and cos. So it is sine beta divided by cos beta is equal to y sine alpha divided by 1 minus y cos alpha. So from this second given condition also, let us get the value for y. Okay. So first of all, you have to do cross multiplication, or let us cross multiply it. Y, this is your sine alpha. Sine alpha cos beta, it is cross multiplied. Y sine alpha into cos beta is equal to, this is your sine beta minus y cos alpha sine beta, minus y cos alpha sine beta. Okay. Now since we are getting the value for y from the second given condition, so let us keep the terms containing y on the left hand side. That means minus y cos alpha sine beta, take it to the left hand side, so it becomes plus, isn't it? Y sine alpha cos beta plus y cos alpha sine beta is equal to sine beta. Understood now? So what is common out here? Here y is taken common, so within bracket what do we have? Sine alpha cos beta plus cos alpha sine beta, which is equal to, this is sine beta. Understood? So let us simplify it. Or y into, this is the formula, sine a cos b plus cos a sine b. What is the formula? Sine of a plus b is equal to sine beta. So let us mark it number 2. Okay. So we have simplified the first given condition and the second given condition, and we have marked them as 1 and 2. So what will you do with this 1 and 2, so that we can prove that sine alpha by sine beta is equal to x upon y. You should get sine alpha divided by sine beta. That means you can divide 1 by 2, isn't it? So let us write here dividing 1 by 2. Dividing 1 by 2. So let us divide 1 by 2. Okay. So you can divide left hand side. You can divide left hand side as well as right hand side from 1 and 2. So let us divide 1 by 2. Now you have to write down left hand side of number 1 in the numerator. So let us write down left hand side of number 1 in the numerator. That is x sine of alpha plus beta divided by, in the denominator you should write down the left hand side of number 2. That is y sine of alpha plus beta. Y sine of alpha plus beta, which is equal to, now on the right hand side you have to write down, in the numerator you have to write down right hand side of number 1 in the numerator, that is sine alpha. From 1 we have sine alpha divided by, in the denominator you should write down the right hand side of number 2, that is sine beta. That is your sine beta. So I think you have understood it. Okay. So we can cancel this sine of alpha plus beta. Sine of alpha plus beta will be cancelled. So or this is x upon y is equal to sine alpha divided by sine beta. So now you can change the side. Sine alpha by sine beta, take it to the left hand side, and x by y, take it to the right hand side. So you don't have to change the sign out here, isn't it? It will be minus sine alpha by sine beta is equal to minus x by y. Minus minus will be cancelled. So you will get sine alpha by sine beta is equal to x upon y. So it is proved. Sine alpha by sine beta is equal to x upon y. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 12. The question is, if tan theta plus tan phi is equal to x and cot theta plus cot phi is equal to y, then you have to prove that cot of theta plus phi is equal to 1 upon x minus 1 upon y. So what are the two conditions given here? There is a value for x is given, that is tan theta plus tan phi. And here the second given condition is y is equal to cot theta plus cot phi. You have to prove that cot of theta plus phi is equal to 1 upon x minus 1 upon y. Okay. So let us prove this relation from the right hand side, because we know the value for x and y, isn't it? So let us prove it from right hand side. So therefore RHS is equal to 1 upon x minus 1 upon y. 1 upon what is x out here? It is tan theta plus tan phi. It is tan theta plus tan phi minus 1 upon what is y here? It is cot theta plus cot phi. Understood? So next, what will you do here? Since you have to prove this 1 upon x minus 1 upon y in terms of cot, let us convert this tan theta and tan phi in terms of cot. Okay? So which is equal to 1 upon, what is tan theta here? It is 1 by cot theta plus what is tan phi? 1 upon cot phi. Is it clear? We minus this second term is kept as it is, 1 upon this is cot theta plus cot phi. Understood? So now let us simplify the first term. Let us take the LCM here. So 1 upon, what's the LCM in the denominator? We have here cot theta cot phi. So now it becomes cot phi plus cot theta. So you know how to simplify it, isn't it? We have taken the LCM and simplified the denominator. Okay, minus 1 upon this is your cot theta plus this is your cot phi. Okay, now if you simplify the first term, when this denominator goes up in the numerator, it becomes upside down. So you should write cot theta cot phi in the numerator divided by cot theta cot phi divided by what? Cot phi plus cot theta. It is cot phi plus cot theta, then it is cot phi plus cot theta minus 1 upon this is your cot theta plus cot phi. Is that understood? So I think you have understood it. So let us take the LCM. So what's the LCM here? LCM here is cot phi plus cot theta is the LCM. Okay. So what will be in the numerator? It is cot theta cot phi, then this is minus 1. So what is the formula there you can use here? This is cot A cot B minus 1 divided by cot B plus cot A. Here theta is taken as A and phi is taken as B. Theta is taken as A and phi is taken as B. So this is the formula cot A cot B minus 1 divided by cot B plus cot A. What is the formula? That is cot of A plus B. But here it is cot of what is A? Theta plus what is B? It is phi. So we have done it. So which is equal to right hand side. So it is proved. So I think you have understood it. Okay. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 13. The question is, if tan theta is equal to 2x minus k upon k root 3 and tan psi, this is known as psi, this is a Greek letter, okay, this is your psi, right? So this is a Greek letter, you should know it. So tan psi is equal to x root over 3 divided by 2k minus x, and you have to prove that psi minus theta is equal to 30 degree. So from these two given conditions, that is the values for given values for tan theta and tan psi. There is given values for tan theta as well as tan psi. From these given values of tan theta and tan psi, you have to prove that psi minus theta is equal to 30 degree. Okay, so these are the given values of tan theta and tan psi. So let us first find out the value for tan of psi minus theta. So let us get the value for tan within bracket psi minus theta. So which is equal to, what is the formula that you can use here? Tan of A minus B, that is tan psi minus tan theta, tan A minus tan B divided by 1 plus tan A tan B. Is that clear? So now in the next step, let us put the value for tan psi as well as tan theta. Okay, so what is the value for tan psi here? What is tan psi? It is x root 3 divided by 2k minus x minus, what is tan theta? It is 2x minus k divided by, it is k root over 3 divided by 1 plus, what is tan psi now? It is x root over 3 divided by 2k minus x, that is your tan psi. And what is tan theta? It is 2x minus k divided by, it is k root over 3. So is that clear to all of you? So now let us get the LCM both in the numerator as well as in the denominator. So what's the LCM in the denominator? The LCM is 2k minus x into k root 3, that is k root over 3 into 2k minus x into 2k minus x. This is the LCM. Okay, now this LCM is divided by 2k minus x. So 2k minus x and 2k minus x will be cancelled. So we have k root 3. Now k root 3 multiplied by x root 3, that is root 3 into root 3 is 3, and it is root 3 into root 3 is 3, and it is kx. Then minus sign is there. Minus, now this LCM is divided by k root 3, so it is 2k minus x. So 2k minus x is multiplied by 2x minus k. So it is 2x minus k into 2k minus x. So we have simplified the numerator. Let us simplify the denominator again. So what's the LCM in the denominator? It is k root over 3 into, it is 2k minus x. Is that clear? So now how will you simplify it? Now this LCM, this is the LCM k root 3 into 2k minus x, it is multiplied by 1, and you write it here, that is k root over 3 into 2k minus x into 2k minus x, then plus sign is there. Then you should write x root over 3, x root 3, and within bracket we have 2x minus k, and we have here 2x minus k, bracket is closed. Okay, so now you can cancel here, k root 3, 2k minus x will be cancelled. So which is equal to, now let us simplify it. Now it is 3kx, now multiply these two factors and multiply by minus sign. So minus 2x into 2k, minus 4xk, right? Minus into minus plus, this is your 2x square, minus into minus plus 2k square, right? Minus into minus plus into minus is minus kx. So it is minus kx, right? So now let us simplify this denominator. K root 3 into 2k, it is 2 root 3, it is 2 root over 3 k square, 2 root over 3 k into k square minus root 3 kx, right? Then plus this is 2 root over 3 x square, right? Plus and minus, this is root over 3 kx. So I think you have understood it. Okay, so now let us simplify it, which is equal to, now 3kx, let us write here 3kx minus 4xk minus kx, same sign, you have to add them, minus 5xk plus 2x square plus 2k square. This whole divided by, now in the denominator, what do we write? So in the denominator, here we have 2 root 3 k square. This is the only expression here. Minus root 3 kx minus root 3 kx. Same sign, you have to add them. Minus 2 root over 3 kx. Okay. Then plus 2 root over 3 x square. Plus 2 root over 3 x square. Okay. So now, which is equal to, now let us write this 2x square plus 2k square, and this 3kx minus 5kx. These are similar terms, you can simplify it, but they are of opposite sign, you have to subtract it. So it is minus 2xk whole divided by, in the denominator, what's common here? What is common? 2 root over 3. So within bracket we have k square minus kx plus it is x square. So now in the denominator also, what is common here? 2 is common, right? So 2 within bracket, what do we get? X square, it is x square plus k square minus xk whole divided by, in the denominator you write 2 root 3. So here we have 2 root 3 within bracket, it is k square minus kx plus x square minus kx plus x square. Okay, so here you can cancel these 2 gets cancelled, and this will be cancelled, which is equal to, this is 1 upon root over 3. Is that understood? So this 1 upon root over 3 is the value of what? Tan of psi minus theta. Therefore, this is tan of psi minus theta is equal to 1 upon root 3. But since the left hand side is in terms of tan, you should write 1 by root 3 in terms of tan also. So tan of which angle is 1 by root 3? It is tan 30 degree, or tan of, this is your psi minus theta is equal to, this is your tan 30 degree. So from both the sides you can cancel tan. So what do we get? Psi minus theta is equal to 30 degree. So it is proved. That is, psi minus theta is equal to 30 degree. So it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next question, that is question number 14. The question is, if cos of theta minus alpha is equal to p and sine of theta plus beta is equal to q, you have to prove that p square plus q square minus 2pq sine of alpha plus beta is equal to cos square within bracket alpha plus beta. So from these given values of p and q, that is p is equal to cos of theta minus alpha and q is equal to sine of theta plus beta, you have to prove this LHS is equal to RHS. That is, p square plus q square minus 2pq sine of alpha plus beta is equal to cos square alpha plus beta. So let us prove it. Okay. So let us write down left hand side. So LHS is equal to p square plus q square minus 2pq, and this is sine of alpha plus beta. What is p whole square? If p is equal to cos theta minus alpha, what is p whole square? It is cos square theta minus alpha plus what is q square? Q is equal to sine of theta plus beta. What is q square? It is sine square theta plus beta minus 2 into, what is p? So let us put the value for p. It is cos of theta minus alpha. And what is q? It is sine of theta plus beta, sine of theta plus beta, and this is sine of alpha plus beta. So we are just putting the values of P as well as Q. Okay. So now let us simplify it in order to prove this cos square alpha plus beta. Okay. So let us convert it into sine. You know cos square theta is equal to 1 minus sine square theta. So let us convert this cos into sine by writing 1 minus sine square. What is theta here? It is theta minus alpha. Then it is plus sine square within bracket theta plus beta minus 2 cos of theta minus alpha. It is kept as it is, sine of theta plus beta, sine of this is alpha plus beta. Is that clear? So now let us take common here from these two terms. What is common? Minus within second bracket, it is sine square theta minus alpha, minus into plus, minus sine square, this is theta plus beta. So let us keep it within bracket. So this is the formula sine square A minus sine square B. You can use this formula in this, isn't it? So next, minus 2 cos of, this is theta minus alpha, sine of theta plus beta, and this is sine of alpha plus beta. Is that clear? So which is equal to 1 minus, what is the formula that you can use here? This is sine square A minus sine square B. So you should know this formula. I am writing here sine square A minus sine square B. What is the formula that you can use here? It is sine of A plus B into sine of A minus B. So this is the formula that you can use here. Sine of A plus B into sine of A minus B. 1 minus sine of, what is A plus B here? It is theta minus alpha is A plus, what is B? Theta plus beta into sine of within bracket. What is A minus B here? It is theta minus alpha minus theta minus into plus minus beta. Is that clear? And keep the last term as it is, minus 2 cos of theta minus alpha, sine of theta plus beta, sine of this is alpha plus beta. Okay. So here you can cancel this theta gets cancels. So which is equal to 1 minus sine of within bracket theta plus theta, 2 theta minus alpha plus beta. Okay. Then this is sine of within second bracket, minus is taken common. We have alpha plus beta, second bracket is closed. Then keep the last term as it is, minus 2 cos of theta minus alpha, sine of theta plus beta, this is sine of alpha plus beta. Okay. So now which is equal to, now what is sine of minus theta? You know that this is minus sine theta. Sine of minus theta form is there. What is sine of minus theta? Minus sine theta. So minus into minus plus 1 plus, this is sine of, this is 2 theta minus alpha plus beta into sine of, this one is alpha plus beta. Okay. Next, minus 2 cos of theta minus alpha, sine of theta plus beta, right? Then this is sine of alpha plus beta. Understood now? So next, what will you do? Now let us simplify this 2 theta. This 2 theta can be written as theta plus theta, which is equal to 1 plus sine of within second bracket. This 2 theta can be written as theta plus theta. 1 theta you write it with minus alpha. So this is theta minus alpha plus 1 theta, another theta you write it with beta. That is theta plus beta. Okay. Second bracket is closed. Then this is sine of alpha plus beta minus last term as it is 2 cos of theta minus alpha sine of theta plus beta. This is sine of alpha plus beta. Is it understood now? So what is the formula that you can use here? This is sine of a plus b. This theta minus alpha, take it as a. This theta plus beta, take it as b. So this is your sine of a plus b. So let us use the formula, which is equal to 1 plus. This is 1 plus. So next we have 1 plus. This is the formula, sine of a plus b. 1 plus within second bracket. What is sine of a plus b? Sine a cos b. Sine, what is a? Theta minus alpha. What is cos b? Cos of theta plus beta. That is sine a cos b plus cos a sine b. Plus cos a. What is cos a? Here sine a is sine theta minus alpha. Cos b is cos theta plus beta plus cos a. What is cos a? Cos a is theta minus alpha. And what is sine b? Sine of theta plus beta. Sine of theta plus beta. Second bracket is closed. Then outside this second bracket you should write sine of alpha plus beta. It is sine of alpha plus beta. Okay? Then you have to write down the last term. As there is no space there, let us write it in the next line. That is minus, this is the continuation line, right? Minus 2 cos theta minus alpha. This is theta minus alpha sine theta plus beta. Sine theta plus beta. Then you should write sine of alpha plus beta. Then this is sine of alpha plus beta. Is that clear? So next, let us simplify it. Which is equal to 1 plus. Now we can multiply this sine of alpha plus beta by these two terms. So let us open the bracket. Sine of theta minus alpha cos of theta plus beta sine of this is alpha plus beta. Okay, then again plus into plus, plus again you should multiply sine of alpha plus beta by the second term, that is cos of theta minus alpha sine of theta plus beta sine of alpha plus beta. Okay, and the last term is, this is the continuation line, minus 2 cos of theta minus alpha sine of theta plus beta sine of this is alpha plus beta. So is there any term you can simplify? So which are the similar terms here? Cos theta minus alpha sine theta plus beta sine alpha plus beta, and minus 2 cos theta minus alpha sine theta plus beta sine alpha plus beta. These are two similar terms, but they are opposite sign. You can subtract it, isn't it? So you can write which is equal to 1 plus sine of theta minus alpha cos. This is cos theta plus beta sine of alpha plus beta, and this third term and last term, if you simplify it, what do we get? Minus cos of theta minus alpha sine of theta plus beta into, this is the continuation line, sine of alpha plus beta. This third term and fourth term are simplified. This is just like your a minus 2a, that is your minus a. So it is minus cos of theta minus alpha sine of theta plus beta sine of alpha plus beta. So I think you have understood it. So now again you can simplify this second term and the last term. Is equal to 1 plus, what is common out here? So sine of alpha plus beta is common out here. So within second bracket, what do we get? Sine theta minus alpha, then cos of theta plus beta. Cos of theta plus beta. then minus sine. Next, cos of theta minus alpha, cos of theta minus alpha, then sine of theta plus beta, then sine of theta plus beta. So in this case, from this second and third term, sine of alpha plus beta is taken common from this second and third term. So what do we get? Sine theta minus alpha cos theta plus beta minus cos of theta minus alpha sine of theta plus beta. So now what is the formula within second bracket? It is sine A cos B minus cos A sine B. What is the formula? Sine of A minus B. So is equal to 1 plus sine of alpha plus beta into, what is the formula? Sine of A minus B. What is A? Theta minus alpha minus theta minus into plus minus beta. This is the formula. Sine of A minus B. That is, A here is theta minus alpha minus B minus theta minus into plus minus beta. So here theta theta will be cancelled, which is equal to 1 plus sine of alpha plus beta into sine of within second bracket. What is common out there? Minus is taken common within bracket alpha plus beta, right? So which is equal to 1 plus sine of alpha plus beta into, what is sine of minus theta? What is sine of minus theta? This is just like your sine of minus theta. That is your minus sine theta. Clear? So which is equal to 1 plus into minus is minus, sine into sine is sine squared. It is alpha plus beta, which is equal to, what is the formula now? What is 1 minus sine square theta? It is cos square theta. So it is cos square alpha plus beta. 1 minus sine square theta is cos square theta, but here theta is alpha plus beta, so it is cos square alpha plus beta. So we have proved it. That is, which is equal to right hand side. That is your cos square alpha plus beta. So it is proved. So I think you have understood it. So this is quite complicated problem, but you can do it. So you can copy it. Now we'll do the next question. So now we'll do the next problem, that is number 15, number 1. So you have to eliminate theta and phi. What do you mean by eliminate theta and phi? You have to remove theta and phi. From the equations, sin theta plus sin phi is equal to A, cos theta plus cos phi is equal to B, and it is also given that theta minus phi is equal to alpha. So using these given relations, you have to remove or eliminate theta and phi. So let us do this problem. So what are the two given equations here? It is sin theta plus sin phi is equal to A, and cos theta plus cos phi is equal to B. Let us mark it as number 1 and this as number 2. Okay. So now you have to simplify this 1 and 2. So how can you simplify this number 1 and number 2? Let us square both the sides of 1 and 2 and then add them. Okay. So let us square both the sides of 1 and 2 and then add them. Okay. So let us write here squaring both the sides. Squaring both the sides of 1 and 2. So let us square both the sides. So what do we get? This is sin theta plus sin phi whole square is equal to A square. And again, what is the second one? Cos theta plus cos phi whole square is B square. So let us add them. Let us add it. Okay. So what do we get? Therefore, sin theta plus sin phi whole square plus this is cos theta plus cos phi whole square is equal to, this is your a square plus b square, right? So let us simplify it. A plus b whole square, this is sine square theta plus what is twice ab, 2 sine theta sine phi plus what is b square, it is sine square phi, okay? Plus similarly this is also a plus b whole square, a square cos square theta twice ab, 2 cos theta cos phi 2ab plus b square. What is b square here? This is cos square phi. Is that clear? So which is equal to, now this is a square plus b square. So I think you have understood it. So this is the continuation line, right? So I have written it in the next line. Actually this is the continuation line, right? So now next, or what is this sine square theta plus cos square theta? What is this sine square theta plus cos square theta? That is your 1. Let us write here 1 plus, similarly what is sine square phi plus this cos square phi, that is also 1 plus 1 plus, now from these two terms 2 cos theta cos phi and 2 sin theta sin phi, let us take common from here. What is common here? 2 is common. So 2 is taken common within bracket. What do we get? Cos theta cos phi. It is cos theta cos phi, isn't it? So cos theta cos phi, then plus 2 is taken common there, it is sin theta sin phi. So let us write here plus, it is sin theta sin phi, which is equal to, so on the right hand side what do we write? A square plus b square. On the right hand side you should write a square plus b square, okay? So this is 1 plus 1 is 2 plus 2 into, what is the formula that you can use here? Cos a cos b plus sin a sin b. What is the formula? Cos of a minus b, that is theta minus phi, which is equal to, this is a square plus b square. Or now again in this case you can put the value for theta minus phi from the question given. Theta minus phi, its value is given in the question. What is theta minus phi is equal to? Alpha. So it is 2 plus 2 cos alpha is equal to a square plus b square. So this is the answer. So in this equation we have eliminated theta and phi. This is known as the required eliminant of theta and phi. Which is the required eliminant? Which is the required eliminant? Which is the required eliminant? So in this case we have removed theta as well as phi. So this is the final answer. So I think you have understood it. So you can copy it. Now we'll do the next question. So now we'll do the next problem, that is 15 number 2. Let us eliminate theta and phi from the relations tan theta plus tan phi is equal to x, cot theta plus cot phi is equal to y, and theta plus phi is equal to alpha. So you have to eliminate theta and phi from these given relations. So let us do this problem now. Okay. So now in this case, let us find out the value for 1 upon x minus 1 upon y first. Is that clear? So in order to eliminate theta and phi from the relations, given relations, let us get the value for first 1 upon x minus 1 upon y. Okay. So which is equal to 1 upon, what is x out here? It is tan theta plus tan phi. It is tan theta plus tan phi minus 1 upon, what is y? It is cot theta plus cot phi, right? So let us convert this cot theta and cot phi in terms of tan. So let us convert this cot theta and cot phi in terms of tan. 1 upon, this is your tan theta plus tan phi minus 1 upon, this is your 1 upon tan theta, isn't it? Cot theta in terms of tan is 1 upon tan theta, plus cot phi in terms of tan is 1 upon tan phi. So let us simplify the second term. So it is 1 upon, this is your tan theta plus tan phi, right? Minus 1 upon, what's the LCM here? LCM here is tan theta tan phi. It is tan theta tan phi, so it is tan phi plus tan theta. You know how to simplify it, right? So in the next step, which is equal to 1 upon, this is your minus sign, right? So 1 upon, this is tan theta plus tan phi, this is tan theta plus tan phi, right? Then minus, now let's simplify this second term. When you take this denominator to the numerator, it becomes upside down. So numerator will be tan theta tan phi divided by, in the denominator what do we write? Tan phi plus tan theta. Tan phi plus tan theta. Is that clear? Now let's take the LCM. So what's the LCM in this case? It is tan theta plus tan phi is the LCM, right? So in the numerator we have 1 minus tan theta tan phi. So we have simplified it, okay? So now in order to use the formula, you know the formula of tan of a plus b, which is equal to tan a plus tan b divided by 1 minus tan a tan b. Let us again take this 1 minus tan theta tan phi to the denominator. So it becomes 1 upon, what is here? It is tan theta plus tan phi divided by, what is there in the denominator here? It is 1 minus, it will be tan theta plus tan phi divided by 1 minus tan theta tan phi. So I think you have understood it, okay? So which is equal to 1 upon, so let us use the formula of tan a plus tan b divided by 1 minus tan a tan b. Here theta is a and phi is b. So what is the formula? It is tan of theta plus phi. So in order to get this tan of theta plus phi, we are getting the value for 1 upon x minus 1 upon y. In order to get tan of theta plus phi, we are simplifying, or we are getting the value of 1 upon x minus 1 upon y. Is that clear? So which is equal to 1 upon, this is tan of, what is theta plus phi from given? From given theta plus phi is alpha. That is 1 upon tan alpha. Okay. So now this 1 upon tan alpha is the value for what? This 1 upon tan alpha is the value for 1 upon x minus 1 upon y. 1 upon x minus 1 upon y is equal to what? It is 1 upon tan alpha. It is 1 upon tan alpha. So let us simplify it. So what's the LCM? LCM is xy. So in the numerator we have y minus x is equal to 1 upon tan alpha. Okay, let us cross multiply it, or xy is equal to y minus x into what? It is tan alpha. So in this relation, theta and phi are eliminated. So this is the required eliminant. So we have removed theta and phi from these three given relations, and we got the relation xy is equal to y minus x into tan alpha, and in this relation theta and phi are eliminated. So this is known as, which is the required eliminant. This is known as eliminant, okay? Which is the required eliminant. Which is the required eliminant. So this is the answer. So I think you have understood it. So you can copy it. Now this much is for today. So today also we did some problems, but some problems are quite complicated. You do revise at home. So if you have any difficulties, you can call me. Okay, so in the next online class we will do more problems on these trigonometrical ratios of compound angles.